Hey everyone, welcome to Simplilearn's YouTube channel. In this session, we will be covering the object-oriented programming in Java. In this tutorial, we will discuss the following concepts: classes and objects, access modifiers, inheritance and protected access modifiers, encapsulation, abstract classes, interface, multiple inheritance in Java using interfaces, and finally, we will cover some of the projects based on our learnings, that is ATM project and calculator project. So before we begin, make sure that you have subscribed to our YouTube channel and don't forget to hit that bell icon to never miss an update from Simplilearn.
Hello guys, this is Vikesh and let's get started with today's topic, which is about classes and objects in Java. So like I have been promising in the previous sessions that I will cover this in a dedicated session, and this is the session where we will go deeper into the concept of classes and objects. You have been seeing this keyword all along in all the sessions wherever I ran the different examples. And let's understand what this means. Technically, if you go by the definition, a class is basically a blueprint of an object, which brings the question as what is object? An object is basically an instance of the class. I know this becomes more confusing, so let's break it down into simpler definitions. A class is technically a logical entity. You can think of it as any entity in the world. If you have to, let's say, if you have to build a student management system or a college management system, then all the real life objects which you see, we always say that Java is heavily inspired from real life examples, and classes and objects are the reason we say that, because whatever you see in the world is always basically some entity. Human beings are an entity, cars are an entity, students are an entity, lecturers are an entity. So all the actors which you see in the world are basically entities, and you can map them as classes in the Java program. Now, why do you want to map them? Because these entities have basically two kind of specifications. One is every entity will have some attributes and it will have some behavior. And actually that is how you identify an entity. For example, human beings have attributes like we have hands, we have eyes, we have ears, legs, etc. These are our attributes. Then we have our behaviors. Behaviors are actions. You can think of them as a human being can speak. So can speak is an action, it's a behavior. Can listen is an action, it's a behavior. Can walk is an action, is a behavior. Similarly, can eat is also an action or a behavior. So that's how you basically represent an entity. That's how basically you identify an entity, that an entity will have some attributes and some behavior. If you see those two specifications in any entity, you can map that entity, or you can write that entity inside a Java program as a class, because a class in Java will exactly have these two properties. It will have some attributes, which we call as properties, and it will have some behaviors, which technically are called as methods. So it will have attributes, it will have properties and methods, similar to real world entity where we have attributes and behavior. Behavior are methods and attributes are properties. That's how it is. So if you apply this simple philosophy, whenever you are taking requirements from a customer for a particular project, always try to identify these entities, these actors in your program. Once you have identified those, you will be able to write a corresponding Java class in your Java program, which can represent those entities. And without representation of those entities, you cannot write the program. So Java will kind of force you to think in this direction, to find entities which will have attributes and behaviors. So taking that philosophy further and taking that example further, here for you, I have prepared an example where I am creating a student class. So basically, let's say if you have to build a college management system or a student management system, then student is probably one of the main entities which will be talked about when you take the requirements. So if you think about the attributes and the behavior concept, a student will have a name, will have an age, will have an address, and at the same time, a student can also have some behaviors, like can enroll in a particular course, can attend a lecture, can take a leave, can take exam, etc. These are all behaviors. Let's understand this in a more detail with the help of this example where I've created a class which is named as student. And you see the public keyword here. Again, I will cover access modifier. Public is basically an access modifier, and I will cover this in very detail in the upcoming sessions. For now, let's focus on this part. So we have created a class to represent our entity. You put a curly braces around it. It ends here. And after that, you provide the attributes. So here I'm saying that a student will have a name, it will have an age, and it will have an address. It has three properties. So the technical name of attributes is properties. After that, let's skip this part and I will come back to this part. Once you have declared these properties, you would want to provide a way for the name to be filled or replaced or received. For example, if you have created the student class, how do you insert the name inside the student class? Or how do you insert the age, or how do you insert the address or modify the age, name, or address properties? For that, we have these setters and getters methods. We call them setters and getters because they start with this keyword, not keyword, but they start with a string called set. It is not a keyword. You can actually write it as anything. You can call it as modify name. That will also be absolutely fine. Java will not give you an error. But the standard naming convention given by Java is to start the methods as starting with set and get. This is the standard naming convention. And like I said, it's a naming convention. It's not a compulsion. But if you write this way, your code developers and the people who are going to maintain this project in the longer run will be very happy. Otherwise, they will be very angry if you use strange methods, because like I said, this is the standard naming convention. So now you are going to write a setter method for each of the properties in this particular class for name, age, and address. So we call set name. Again, you put public void because this is not supposed to return anything. This is just supposed to set the value of name with whatever value you specify. Then you call set name, and then you provide the value which you are supposed to set against the name. So whatever value, like any random name, John or Jane, whatever, you need to supply that name here while you call this method. And that name, whatever name you supply, will be set against the name property of this particular class. And remember, I use the word this here intentionally because the way you are going to represent this is with the help of this keyword. This keyword means current object. It means that when you use this dot name, it is referring to the current object's name property. And this name is basically corresponding to the name which is coming in when somebody is trying to set a name. Similarly, for set age, age is a numeric number. If you observed, it's basically an integer. Then I'm saying int age, and whatever value of age will be coming will be set in this particular object's age. Then similarly, for set address, we have a string address argument being passed into this method, and this gets set inside the current object's address property. So I've provided a way for the external world to set the values of name, age, and address, because for each student, you would need to set these values. Now, you also need to provide a way to receive the values or to return the values or to read the values. For reading operation, you need to provide the getter method. So you see this get, again, this is not a keyword, it's a standard naming convention. So similar, when you wrote set name, similarly, you will write a get name method. This get name method is supposed to be reading the current object's name's properties value and will return that value. Since name is a string, that's why you see the return type as string here. Similarly, get age is going to return the age, which is an integer, and address is going to return the address. You can also write it like this, which is absolutely fine. It is not going to complain because technically it is returning the current objects, name properties and age property and the address property. Now let's talk about this. What is this section? So this section is basically called a constructor. And I have a whole session dedicated on the constructors, but let's understand why we need this. Remember when I told you the definition of the class, I said that class is a blueprint of an object. So you have created a student class and you have 5,000 students in your college. Now you need to create a new student object for each of those students. You need to initialize this student class 5,000 times. How do you do that? To do that, we do that with the help of constructors. We call this constructor. This is a special type of method. Remember, this is a special type of method which is provided by Java to initialize any class's objects. If you want to create multiple objects of the student class, you can repeatedly call this student constructor. We call this constructor. So you put public here because we want this constructor to be accessible to the outside world. Then you put the exact class name. So whatever class name you have provided here, you need to put the exact class name here. If you don't do that, Java is going to raise an error. If I do this here, it is going to, you see a red line here because Java failed to compile this constructor. It does not understand what is student 111, but it does understand what is student. So this is how it is going to be. And then you provide all the properties which are going to create the student object. So you're going to create the name, the age, and the address. So the name, age, and address. And then you set those values again, similar to the setter methods we have seen. The reason we need to use this here because if you write it like this, then Java doesn't understand the difference between the current object's name and the name coming from the argument. So to differentiate that, you need to use this here. If you use n here, and if I just use n here, then this is fine because there's only single name variable in this whole class then. But if I write it like this, then Java doesn't know if this name is basically the student class's name or this name is student class's name. It will get confused, like you are getting confused if you try to just find this in a mind mapping. So that's why we need to write this here so that it's clearly differentiable that whenever I use this dot name, I'm referring to the class's name property. And when I'm just using the name, I'm referring to the method argument. That's what we do in this constructor. So you basically initialize all the properties of your class with some values with the help of constructor. So we have the constructor, we have the setter, we have the getter. We can cover about this toString. Basically, this toString is to print something, but we can cover that later. Now let's initialize this particular class. So I'm similar to the initialization we have seen so far. You just write student. You write the object name, this can be anything, and then you use the new keyword, which is used to initialize anything in Java. New is a keyword in Java, which you can use to initialize literally anything in Java. So you use new student, and when you say new student, you can provide all the values which should match its constructor. So here we have three values, string, integer, and string. And here also we are supplying three values, string, integer, and string again. So remember to match this exactly with one of the constructors which is available in the class. If it doesn't match, it is going to fail. It will not work. So if I, for example, if I do this, then I'm supplying 4 arguments to the student class, but there is no constructor matching 4 arguments, so it is going to complain. You see this red line and the code is not compiling. If I remove this, then it is matching it. And that's how you basically create a student object. So an object is basically an instance of the class. Remember that very well. An object is an instance of the class. Once you have created an instance of the class, then you can call any method like say, let's say you want to read the name. So you can call get name. You can read the name. Similarly, if you want to if you want to read the age of the student, then you can do that as well. So let me just copy this and do this. Let's call get age. I want to print the name, I want to print the age, and I also want to print the address. So get control space, I get suggestion address. Yep. So I'm printing the name, I'm printing the age, and I'm printing the address after I have initialized the object successfully by using this constructor representation using the new keyword. So now let's run this method or run this class basically. Okay, so when I ran this class, the whole class got compiled, the constructor, the getters and the setters and the properties and their types, everything was set. Then the main got called and I created a new object from this class's blueprint. The object name was John. Then I called john.getName to print the name which is stored inside this particular instance of the student class. Similarly, the age which is stored in this particular instance. So we stored the name as John. So when we call john.getName, we get John. When we call john.getAge, we get the age 25. And when we call john.getAddress, we get this particular address. Whatever values you specified here, the constructor got called here, and the name John got set to the student's name value. the age value which you supplied got set against the student's age, and the address value which you supplied got set against the student's address. And that's how you're going to create a class. So remember, whenever you create a class, identify the properties and the behaviors like setters and getters. Write a constructor which can cover all the values which you want to initialize. And after that, just initialize that class, create an object of that particular class basically. And once you have the object, then you can call getters. You can also call this in this way. If I don't supply any of this, then currently it complains. And why it complains, I will cover that in the following session when I will cover the multiple constructors concept. But remember, you see this behavior here that if you have created a constructor which accepts some arguments, and if you supply this kind of initialization, then student class does not have a constructor which is parameterless. Student class has only one constructor which is taking 3 parameters. And that's why Java complains, because it is not able to find a representation of a constructor which accepts no parameter. But like I said, we will cover this. We will find a solution to this particular problem in the coming session. But for this session, this is all we are going to cover. We covered about classes, we covered about objects, and we also saw how we can write getters and setters. We can initialize those methods, initialize those objects, and we can access the properties of those objects using the getters. And we can also call the setters to modify the values as well, similar to this.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Let's get started with access modifiers in Java. So when we talk about access modifiers, let's understand what is the underlying philosophy of the reasoning behind this. And the reasoning is very straightforward. It can be even wrapped into a single word, which is called security. The reason is that you will be creating multiple kinds of objects and variables while you write your Java program. And you should always write your Java program or any program in a manner that only the intended classes, packages, modules, or applications should be able to see what they are supposed to see. So as a consumer application, I should only be able to consume the variables which I am expected to consume. I should not get any variable, or I should not even have access to any variable which I am not supposed to access. So the idea is providing the least privilege principle. Give access to different functions, different variables, different programs only by providing them the kind of access which they need to run efficiently, and do not give them complete access. So with that notion in mind, Java created the concept of access modifiers, and it created these 3 modifiers, which are called public, protected, and private. If you do not provide any modifier, then it goes to no modifier, or some people also call it as default modifier, which is also a type of access modifier. So let's understand theoretically first how it works, and then we will try to have a look at an example. Let's understand the first one. First of all, these modifiers are keywords, and you can use these keywords in front of classes, in front of variables, and also in front of methods. And you might have already noticed this particular keyword called public in front of all the classes I've created, or even when we talked about the public static void main method, we saw this public as a keyword. It is basically an access modifier. And whenever you put public in front of a class or a variable or a method, that particular component becomes available to the whole of the program. It will be available to the whole world basically. Any subclass or any package or any other class which might have been written in your Java program will be able to access that particular class or variable or method if you put public in front of that. The second modifier level is protected. One of the other thing which you will understand as I explain this is that as you move down into this particular table, the access level will start getting more and more restricted. And by restriction, I mean that less and less components will be able to get access to those modifiers. So if you write protected in front of a class or in front of a method or in front of a variable, then everything within that particular class will still be able to access it. everything within the package will still be able to access it. I still haven't covered the concept of package, but I briefly touched upon it, showing you how whenever we write a class, we have a package in front of it, and package is technically is just an aggregation of the classes. If you have to write multiple classes and wrap all of those classes into a single logical bundle, that would be called a package. Just to show you an example, these all are packages which you see here. You see this square box here, and you see these names, these all are packages. And these packages contain multiple classes. And technically, that's all the packages mean, that you can wrap multiple related classes into a single package. So coming back to the access modifier, whenever you write protected in front of a class or a variable or a method, then that particular component will be accessible to everybody within the same class, everybody within the same package. It will also be accessible to everybody which is a subclass of the class. This is again a new concept which I have not covered, but this basically means a child of this class. Now, what is a child of the class? We will cover that concept in detail when we will talk about inheritance. But for now, you can understand that it is basically an extension of the class. So when the moment you declare something as protected, it can easily be accessible within the same class in which this protected component was declared. It can be accessed in the package. It can also be accessed in the subclasses of the class, but anything outside the package will not be able to access it because you see an N here. Then we have the default access modifier or no modifier. If you do not write anything in front of a class or a method or a variable, it gets the default access modifier privileges. And that privilege means that anybody within the same class will be able to access that default variable or a default component. Anybody within the package will also be able to access it. The subclasses of the class where the default component was declared, those subclasses will not be able to access it. And anybody outside the package will obviously not be able to access it. Then comes the last one, which is the most restricted privilege, which is called private. So if you put private in front of a class or in front of a method or in front of a variable, that component will only be accessible within the class where it was declared. It will not be accessible in the package. It will not be accessible in the subclasses and definitely not be accessible to anybody outside the package. So private is the least privileged or least access permission level you have in Java. Once you write private in front of any component, that only the classes, other variables, the same class in which you declare this particular private variable, only that class itself will be able to access it and nobody else will be able to access it. And as you move above, the accesses become more and more lenient. You can see there's just one Y and 3 N here. The moment you move a bit above to the default modifier, you get 2 Ys. So everybody in the class and everybody in the package will be able to access that particular component. For the rest of the other world, it is still unknown. When you write something as protected, then everything in the class, everything in the package, and everything in the subclasses will also be able to access it. Rest of the world cannot access it. And if you write something as public, then anybody can access it. It's like Y everywhere. So that is how the access levels work. Now let us understand this with the help of example. So I will go here and I've just written a very simple dummy class here, which is a class called test. And I have a method here, which is a display method. So very simple class, nothing fancy here. And if you notice, I have not put any kind of public, private, or protected modifier in front of the class. So this will get the default privilege. If something has default privilege, then the whole world will not be able to access it. So let's go to a different package. Let's go to this package, which is here. And let's try to access this particular test class. So we will try to access this test.java here in the main class. So let's try to do that. Let's say test t equal to new test. I'm just initializing the same class. So what do I get? I get a compile error. Let me try to fix it if I can, and I cannot fix it. If you see, I'm just trying to use this particular test class into a different package, but that package is not able to see the class at all. I'm getting a compilation error, and if I try to click on the error, generally Eclipse provide me suggestions to import this particular class. But Eclipse is not able to find any class with the name of test, which can be imported in this package, which is a different package than the one of the test class. So we cannot access it because it's in the default access. Now let's go back to the test class and let's make it public. So I've just made it public here. And now if I click on this again, I get the suggestion. If you see, this suggestion was not there earlier. Now it says import test. And if I click on this, double click, it gets imported and everything is happy. So you can see the whole access modifier in effect here, the default versus public. You can also try the other kind of access modifiers. Let's try private as well. I think private will also have the same effect because it will still not be accessible from the package or from the subclass or from the whole world. We already saw this particular in effect, but we'll see the private in a different way now. So going back to the test class, I've made the class as public, but the method here is default. I've not exposed this method to be used outside the class. Let's see what happens if I try to call this display method from the main class. So I have successfully initialized the class, and if I say t dot, and if I look at the suggestions here, I do not get the suggestion of the display method. Why? Because it is default. If I go back, make it private, can I now access it? Let's try again. Nope, still we can't access it. Eclipse is not even able to find it inside this package because it is private. Let's go back and make it public. So I've made it just public now. Going back to the main class and again saying t dot, now I get the display suggestion as the first suggested method here. And now I am able to use the display method once I have made it public. So you see, the moment you change the access modifiers, the changes are propagated immediately. And you can see the public versus default versus private in play here. We can even go into further detail by using the protected, but for protected, I have to explain the concept of subclasses. So I will cover this protected versus subclasses concept when I talk about inheritance, and there we will see the usage of protected variables and the protected access modifier. But we saw the usage of public, the default modifier, and the private modifier. Do check out the documentation for these access modifiers, and I would strongly suggest you to play around with this, get more comfortable with this concept of different kind of modifiers. Let's also run an example for understanding the default modifier in a better sense, because we can see that for the package, it says Y, right? So let's go back to Eclipse, and within the same package where we created test class, let's create another class. Let's call it test demo. So I will just click finish. I get a new class. Let me also write the public static void main method here. So I get the public static void main method here, and let's try to access the test class here within the same package. So let me again go back to the default privilege here. So I put the test class access as the default class or default access, and same goes for display. So can other classes in the same package access the test class now? Let's see that. If I go to test demo, and here if I try to get the test class initialize, does it work or does it give me a compilation error? Yes, it works. It works because the test class and the test demo are in the same package, and test class has the default access privilege. So let's try to run one more variation of it to understand the usage of the private method better. Going back to the test class, this display method has the default privilege right now. So going by that logic, if I say t dot, I should be able to get access to the display method. And yes, that is possible. If I run this particular program, I will be able to get whatever is given out by the display method, which is hello world. Now let's try to make this particular method as private. And let's try to access this method from one of the other class in the same package as of the test class. So the class is default, the method is private. And if you see, this class has already turned red. There is a compilation error because now the display method is not accessible to the test demo class. Even if it was in the same package, it's not accessible because the display method's privilege or access modifier has gone to private now. Exactly the same as explained here. Because it has become private, so the package level members cannot access it. There's an N here. So this was another variation to show you how you can use public, protected, and private together to only expose the members, methods, and classes which are supposed to be exposed to the consumer. This is a very critical and very important concept to be used in Java, and it is used from a very simple program to all the highly complex application. This is sort of the bare bone or the laying foundation for any kind of basic security level premise which you need to build in an application. Let's get started with inheritance. So inheritance is basically one of the most important properties of any object-oriented programming language. It's basically a concept, and the concept says that what if you have a scenario where you want multiple classes to share similar behavior and similar properties. Let's understand this with the help of an example. Let's take the example of a bank. When you go to a bank to open an account, there are multiple types of accounts. There can be a savings account. It can be a type of current account. There can also be a different offering for personal account and commercial accounts, such as for businesses. Then you may also have loan accounts, which are having different kind of properties. So all of these types of accounts are still technically accounts, and they will share some similar properties. For example, all of them will have to maintain some sort of an interest rate. For example, all of them will be used to either deposit money or withdraw money. So there would be some kind of similarity across all of these types of account classes. But at the same time, there will also be some sort of differentiality amongst these classes. The way you will calculate the interest rate for a current account will be different from the way you will calculate the interest rate for a savings account. And the same applies for commercial account, personal account, loan account, etc. So you see that we have some common behavior, but at the same time, we also have some different behavior. So whenever you have such scenario, always think about applying the concept of inheritance in your application. There's another simple way to spot whether inheritance can be used at a particular place or not. Inheritance is also called is a relationship. So whenever you read the requirements from a customer, just try to find the words which use this particular phrase is a. For example, car is a vehicle. Savings account is a type of account. Similarly, you will find many other types of similar examples. So whenever you will see that is a relationship between two different kinds of objects or two different kind of entities, that means that there might be an inheritance relationship being applied between them. And that's how you will spot the usage of inheritance. So far we have understood this concept that there would be some sort of relationship between the two classes. What will be this relationship? The relationship will be of parent-child type. There will be a parent class. Some people also call that as base class. And then there will be a child class. So the child class will be inheriting the properties and the behaviors from the base class or from the parent class. I will be using base class and parent class terms interchangeably during this session. But the basic idea and basic premise is like that only, that there will be a child class and there will be a parent class. And the child class is extending from the parents class. Remember the word extend because we are going to use that. And I've just shown you the what you see here is basically the official definition, which is given by Java docs here. You can read the definition as well. And the basic idea, which I told you, lies in the parent and child relationship. And this is how you can conceptualize it, that you will have a base class or a parent class, and then you can have multiple children of it. And then those children can again have their own children, and so on and so forth. So this hierarchy, this whole inheritance hierarchy, can go as deep as you want it to be. And that's the basic idea and basic conceptualization of how you understand and how you visualize inheritance. Now let's move to Eclipse IDE and try to understand this with the help of an example. So for this particular case, I have created a set of classes basically, which we will be using to demonstrate the relationship of inheritance. And I've taken the simple example of a bicycle. So a bicycle is again a very generic definition of any two-wheeler, and bicycles can have multiple types. There can be an all-terrain bike, there can be a mountain bike, there can be a city bike, there can be a bike which is specifically made for ladies, and similarly there can be multiple different types of bikes. But all of these bikes will have some similar properties. For example, all of them will have two wheels. All of them will have a seat. All of them will have brake. All of them will have some sort of a speeding mechanism, whether they can accelerate or deaccelerate. So there will be some commonality. But at the same time, a mountain bike's features might be very different from a city bike feature. A mountain bike mountain bike might have gears, for example, whereas a city bike might not have gears because you don't need that much of a variation in inclination and declination when you drive down the road. So I'm trying to conceptualize the same example here where I've created a class called bicycle, and this is my base class. I defined two properties in the bicycle class, which is gear and speed. We will come back to protected in a while, but let's leave that there. So I have two properties, which is gear and speed. I have a constructor where I'm initializing the starting speed and the starting gear. And then I have three methods here, which says set gear, apply brake, and speed up. When I apply brake, the speed is going to get reduced. So that's why you see minus equal to unary operator. And when I'm trying to speed up, the speed is going to increase. That's why I'm using the plus equal to unary operator. So when you use the method speed up, the speed is going to be increased by the value you supply in the method. Similarly, when you apply the brake, the speed is going to get reduced by the amount you supply in the method argument. And that is my base class, bicycle, gear, speed, and three methods. Now let's have a look at the child class. So the way you will define the inheritance relationship in Java is by using this extends keyword. Remember, I told you to remember the extends keyword. So what you will do, that you will write your class name as usual, and then you will use extends keyword, and then you will use the parent class name or the base class name. So here I'm saying class mountain bike extends bicycle. And here I'm providing an additional property. Remember the whole commonality versus differentiality equation. So a mountain bike might have an extra property to adjust the seat height. So that's the extra property which mountain bike is having. And then since this mountain bike is extending the bicycle class, this mountain bike class has the responsibility to initialize the bicycle class as well. And the way it will fulfill that responsibility is by taking all the arguments of bicycle class plus the mountain bike class in its constructor. And that's why you see three different properties here. You see the start height property, which is the property of this particular class, which is the seat height. And then you see the start speed and start gear property, which directly are not available in this class, but this class is inheriting those properties from the base class. Remember the keyword inheritance here. And then once you do that, how do you initialize the base class constructor is by calling the super method. This is again a keyword in Java, and you will use this super keyword to refer to the base class constructor in this way. So what you will do technically is that you will write super and you will supply the arguments which is required by the base class constructor. If I go back, the base class constructor requires two arguments, start speed and start gear. So I write super and then I write start speed and start gear. So whatever I got from here in the constructor of mountain bike, I'm supplying those values as is to super. And Java will automatically take care of invoking this particular constructor the moment it encounters this kind of statement. Another thing to notice is that the super keyword or super statement has to be the first statement inside your constructor. Remember that whenever you are dealing with inheritance and whenever you have to initialize the super class constructor or the base class constructor, use the super constructor invocation as the very first statement inside your child class constructor. Otherwise, Java will not compile the program. And then you will initialize the local variable. I should call this as this. Remember, we discussed about this in the classes session. Okay, and then it just has a method of set height. So there's no extra method which this mountain bike is providing, but this mountain bike will have access to all the methods which have been provided here and all the properties which have been provided here. This mountain bike can access everything from the bicycle class. And that's the whole idea of inheritance, that the child class can access the properties of the base class by extending the base class. Now let's look at how do we invoke this particular class. So for that, I have a simple class name as inheritance demo, which has a public static void main method. And then I am initializing the mountain bike class. I'm supplying three values as 20, 10, and 1. So the 20 goes to start height, the 10 here goes to start speed, and 1 here goes to gear or the start gear. And that's how I'm setting the values. So when I call this particular constructor here, the mountain bike constructor is going to, mountain bike constructor is going to get called, and which in turn is going to call the base class bicycle class constructor as well, and everything will be set accordingly. And then let's try to access the gear property. Remember, gear is not directly available in the mountain bike class, but I'm still able to do mountain bike.gear because child class can access the parents class properties. Similarly, the same thing goes for speed as well. And seat height is the local property of this particular class, mountain bike, so it will anyways be accessible. So I can access all the properties of the base class and the child class itself seamlessly without any differentiation. Now let's try to call a method. So here I'm calling the method apply break. Remember, apply break was defined in the base class, not in the child class. It's defined here. So I'm calling the apply break method and I want to reduce the speed, the current speed by 1. And then I'm printing the current speed saying that bike speed after applying brake is mountain bike dot speed. So let's run this particular program and observe the outputs. Okay, so the first statement which gets printed is at line number 7, which says gear is 1 because it's coming from here. Then the seat height is mountain bike dot seat height, which is 20, which is the first argument here. And then the bike speed is 10, which is coming as here and getting printed here. And then when I apply the brake, let's go back to the apply brake method. The logic is that whatever is the current speed, reduce it by the value I supply in the method. So if I supply 1, 10 minus 1 becomes 9, and that becomes the current speed. If I supply 5 here, the current speed will be 10 minus 5 equal to 5. Let's assert that particular assumption as well. Yes, we can see that. And similarly, you can access other methods of the base class as well. If I just do control space here, and you can see apply brake is accessible, set gear, set height, speed up, all the methods which are defined in the base class are accessible in the child class as well. This is the power of inheritance. One more thing which I said I will come back to is around the usage of protected access modifier. Remember when we discussed about the access modifiers in the previous session, I said that protected is used when you are dealing with inheritance, that whenever you define something as protected, it will be available to be accessible in the child classes of the base class. So if I define this particular variable as protected, then this particular property will be accessible in the child class mountain bike as well. Let's play around this. Let's make this as private and see what happens. So if I make this private, now when I say private, the scope of this particular variable is within the class only, and nobody outside the class will be able to see it. And you can see the effect of it. I can see an error being coming here in my inheritance demo class because now mountain bike object cannot access the gear property because the gear property is defined in the base class and now it is private. That's why the child class now, mountain bike class, cannot access the property gear. And the moment you make it back to protected, it will be accessible. The error is gone. There's no red line here. So that's how you can use the protected access modifiers. It is always recommended to use them when you write any kind of inheritance logic. And in inheritance logic as well, intentionally, if you want to hide a particular property from the child classes, just make it private. And that's all I want to cover in this particular session, where we dive deep into the concept of inheritance. We had a look at an example using the bicycle and mountain bike kind of construct, and you can apply the same kind of construct on any kind of other kind of business requirement. Remember, the is a relationship. Let's get started with encapsulation. So again, let's understand what is encapsulation in general, and then we will apply that concept to Java. Encapsulation, if you try to break that word, if I just write it here in the form of a comment, it's encapsulation. Just trying to break this word into to make it more visual. So you see a word called capsule here. So if you try to imagine a capsule, why do you create that, and what's the concept of a capsule? Capsule tries to pack a lot of things inside a small tube-like shape. And the concept of encapsulation is sort of inspired from that. Not exactly, not literally, but that's the basic idea of this root word, which is called encapsulation. So encapsulation basically means to restrict accessing the properties of a class to the outside world. If you want to protect the properties of your class, how do you do that? You do that with the help of the concept called encapsulation. So here, this is a sort of a security feature. You can think of it as a security feature that you want to protect the properties of your class and you will use encapsulation to protect the properties. How you implement encapsulation? Let's have a look at that now. So basic idea is to encapsulate the objects, create sort of a capsule around the object which can provide that protection layer. And you will define how the outside world is going to access the properties of the class if needed. So I've created a simple class here, and it's if you remember one of the previous examples when we discussed about classes, I used the same class, which was the student class, and I'm just using the same class for continuity. So I've created a student class here, and I have created three different properties of this particular class, which is name, name of the student, age of the student, and address of the student. You see, intentionally, I have used the keyword private in front of these three properties. And that is the first thing which you need to do to implement encapsulation on your object, that you hide all the properties from the outside world. Remember, the moment you make anything as private, only the class, which is the student class itself, only the class itself can see these variables or these properties. Nothing outside the student class will be able to access the name or age or the address directly from the student class. It's not possible. That's the whole idea of making it private, because you don't want the outside world to access these properties. So you make those properties as private. Then you create a constructor. The constructor has to be public so that anybody can initialize the student object, because you want your object to be accessible. Remember, so you want the objects to be accessible, but you want the restriction on the access of the properties of the object. And these are the properties of the object. So you have restricted them by making it private, but that doesn't solve the problem, because there will be some illegitimate consumers of the student object which should not have access to the student properties, but there will also be some legitimate consumers of the student object which should be having access to the properties of the student. For example, the payroll application will need access to these particular properties. The examination application will require access to these particular properties. So how do you do that? You create getters. We call them getters because they start with the keyword get. So you create a getter method for each of the property. You create the method called as get name, and this is the naming convention which Java promotes, that you write get and then you write the name of the property in camel case. So you write get name, and this property is supposed to return the name property of this particular object. And here you say return name. So you're returning the name which is being stored by the current student object whenever somebody calls student object dot get name. And this is the way you have restricted the access of this particular object as well. So remember, you made it private so that nobody can access it. And then you defined your own way of providing access to the name property of this particular class. Now, if anybody wants to access the name value of your student object, there's only one way to do that, which is via calling get name. So you have provided restrictions, and you have also provided prescriptive guidance on how you are going to expose the properties of your class. That's the second thing which you need to do to implement correct form of encapsulation on your object. That is to provide the getter methods with the right visibility. You want to make them public so that anybody can call them, but since you are governing which is what is written inside the method, you have full control on what kind of exposure you want to give for this particular property. Similarly, you create a getter for age, calling get age, which returns the age, and then you call you write get address and return the address. Here it is simply returning it, but if you want to do more stuff here, feel free to do that. Like I said, you govern the control of how do you want to return the name. Maybe you don't want to return the complete name and you want to just return the initials. Then you can split the string, trim the string, and return only the initials. So that's the basic idea of getters. Now, after you have created the object, there might be use cases where somebody needs to overwrite the values of the properties like name, age, or address. What if a student's name was incorrectly mentioned when they called the constructor, and now they want to overwrite the name or fix the name? So basically they have to replace the existing value of the name with a new name. So in that case, you need to provide what we call as setters. And they start with set, that's why we call them setters. And we follow the same kind of logic that you provide the setters for all the properties of your class. So you had three properties, which were name, age, and address, and you provided the setters for all three of them. And how do you provide that? You again make them as public because you want the outside world to access this setter method to override the values of the name. This method is not going to return anything, so it is going to be void. Then you write the name of the method, which starts with set, and then the property name in camel case. And then you provide the new value, which is the value which should be the new value, and this is the value which should replace the existing value. So whatever new value you want to supply, you supply that as the argument of the setter methods for set name, for set age, or for set address. And then you write this particular line, which says set the current name property of this particular object with the name which is coming in from the argument. So this dot name, remember, this dot name represents the current object's property because this represents the current object. So whatever is the current object property value of the name is, just override that value with the argument coming in. Do the same thing for age in set age method, and do the same thing for set address in the set address method. So this is how you are going to provide the setters and the getters. So setters and getters can also be generated in smart IDEs like Eclipse. So you just right click, you go to source, and here you will see the option of generate getters and setters. If you click on this, it will give you the list of the fields which are available to be having getters and setters. Currently, it says no fields or all fields have getters and setters already. Yes, because they have it. Let me just comment this and show this how this works. So for example, let me comment all the getters and setters. So I'm commenting them. And if I right click, source, generate getters and setters, I get all the fields available for which setters and getters can be generated. So you can select them and leave everything as default, hit generate. And it is automatically going to generate the getter and the setter. You see, all the code of the getter and setter is automatically generated. You don't even need to write it. And this is the power of the smart IDEs. Let me just revert what I did. So you created everything as all the properties as private, and then you define how you want to replace the values by providing the setters, and you define how you want the outside world to access your properties. So you have full control of the class now. You control the visibility, you control how they are going to get initialized, you are controlling how the properties are going to be overwritten or set, and you control how the properties are going to be returned. So you have complete control of the class. So you have created a perfect capsule here, a perfect form of encapsulation in this class. And this is how you can implement encapsulation. Let's get started with abstraction. Let's first understand the definition of abstraction before we relate this to Java. Abstraction generally means hiding something. When you want to hide some details of a particular object from the outside world, you apply the concept of abstraction. For example, when you drive a particular car, you just hit the accelerator and the car speeds up. Now, it's not only one action. When you hit the accelerator, the whole machinery of the car and all the components, different parts of the car work together to speed up. There would be engine, there would be propulsion, there would be fuel, there might be some, if it's an electric car, there would be batteries, there would be whole different kinds of pistons and plugs which will make the car speed up. It's not only a single component, it's a lot of different components under the hood. And that's the concept of abstraction, that we only show the relevant parts to the user and we hide all the internal details from the user. That's the basic idea of abstraction. So a car manufacturer abstracts away all the inner technical details from the driver and just gives the driver a single pedal to speed up the car. For a user, it's a very good experience because he doesn't need to know about all the internals of the car. But the car manufacturer can hide all the details and provide a very simple interface for the driver to interact with, which is just a gas pedal. And that's the basic idea of abstraction. And we try to apply the same kind of concept to Java in the form of abstraction. And Java provides this kind of concept implementation with the help of a keyword which is called abstract. Now, abstract is a keyword which can be used in front of a class or a method. When you use it in front of a class, the whole class becomes abstract. Abstract class is a type of class. So the class itself becomes an abstract class. One of the things to remember is that abstract class cannot be instantiated but can be subclassed. Remember, we talked about the concept of subclass and the parent class when we talked about inheritance. So if you make a class as abstract class, you cannot call the constructor of the class because you cannot instantiate it, but you can extend the abstract class and create a child class out of it. That's the concept of abstract class. Another concept is abstract method. You can also use the abstract keyword in front of a method. And when you use abstract keyword in front of a method, then that method is only declared without an implementation. You are not going to provide any implementation of the method, and you're just going to declare the method. Something like this. We will see a similar example in the hands-on as well. But that's the basic idea, that you just declare the method. You are not providing an implementation as to what does move to method actually does, because that's the whole concept of abstraction. And it is the responsibility of the child classes which inherit the particular class in which the abstract method would be sitting. So the child class will be having the responsibility to provide a concrete implementation of the declared method. Let's understand this better with the help of an example. So here I have created a class called graphic object, and I have made the class as abstract class. This is the keyword which you need to use in front before the class keyword, and the class becomes an abstract class. Now, when you create an abstract class, it automatically gets some properties. The first property is that this particular class must have at least one abstract method. And this is how you define the abstract methods, where you just provide the declaration, but you do not provide the implementation of the draw method or the resize method. And the way you will create the abstract methods is by using the abstract keyword before the actual method declaration starts. So general method declaration would look like this. And if you use abstract in front of it, this becomes an abstract method declaration. Abstract class can also have concrete methods. So that is the liberty which abstract class gives you, that you can have abstract methods which are just declared, but you can also have normal methods which are where you can also provide the implementation. So you can have normal methods and abstract methods as well in an abstract class. So this is the abstract class. Now, if you want to provide an implementation of the draw and resize method, you have to extend this abstract class. So we extend this abstract class by creating two child classes out of this particular abstract class, which is circle.java, where you can see I create a normal class and I use the extends keyword for inheritance. And I'm saying that circle class is inheriting from the graphic object class, which was my abstract class. And once I use this extends keyword, then I have the responsibility of providing the implementation of the abstract methods. Actually, Java will force me to provide the implementation of these two methods. If I do not provide all the declared methods, so there are two declared methods here. So if the circle class does not provide the implementation for both draw and resize methods, then Java will throw an error and it will ask you to take an action, which can be either define all the methods, meaning provide implementation for all the methods, or make the circle class itself as abstract. Let's see, if I just comment this particular out, I get an error. You see a red line here. And if you click on this particular balloon here, it will say either you can add the unimplemented methods or you can make the circle type as abstract. So these are the two options which you will get to fix this particular error. So an abstract class can be extended by another abstract class if the child abstract class is not implementing all the methods of the parent. If you want to implement all the methods, then just implement them and keep it as a normal class. And that's what I've done here. I've just created a normal class here and provided the implementation. And once you provide the implementation of both of the methods, the error is gone. Similarly, I've also provided another child class because there can be multiple children of a particular parent. So rectangle also extends from the graphic object, and it also provides its own implementation of drawing and resize. Because generally the way you will draw a rectangle and you resize a rectangle will be different than drawing or resizing a circle. Here I'm not doing anything in the methods because this is just to show you the demonstration. I'm just printing a sysout saying drawing a circle and resizing drawing a rectangle and resizing a rectangle, and in the circle class drawing a circle and resizing a circle. So one abstract class is the parent class, which is the graphic object, and two children, circle and rectangle, both providing the implementation of the abstract methods which were declared in the base class. Now let's go to the main class, where I've defined the public static void main method. And here you see I have created two different kind of blocks of code here. One block is where I'm saying graphic object, creating a reference of the graphic object named as circle, and initializing the circle object. Now you see a difference here. Here is the abstract class and here is the concrete class. So whatever you define on the right hand side, whatever is the type of object will be the type of methods being called. So if you created a circle object and then if you call the draw method and resize method, these methods will be called from the circle class. If you initialized it as new rectangle, then you are creating a rectangle class object, and then the draw and the resize method will be called from the rectangle class. That's the basic construct, and that's how you will initialize a particular class which is using an abstract class. So I call graphic object circle, new circle, and I call circle.draw and circle.resize. Similarly, graphic object rectangle equal to new rectangle and rectangle.draw, rectangle.resize. Let's run this program and observe the output. So when I call this particular block of code, circle object gets initialized, and then circle.draw method prints drawing a circle, and circle.resize method prints resizing a circle. Similarly, when I create the rectangle class object, referencing it with the graphic object class, rectangle.draw prints this particular line, drawing a rectangle, and rectangle.resize prints this particular line, which is resizing a rectangle. And this is how you will use the concept of abstraction. There's another very interesting thing which is going on here. Remember, I told you that the abstract classes cannot be instantiated. So if I go here and I try to create a constructor of the graphic object class, let's see what happens. If I do this and I just put a system out here, base abstract class. So if I do this here, if I still write a constructor, though Java says that it cannot be instantiated, if I still write a constructor of it and I do not do any changes here, and if I run this particular program, let's see what happens. You'll see the base abstract class being called here. Let me just reformat it by putting ln here so that we get a better output. So if I run this particular program, you see base abstract class is getting printed somehow, though we said that abstract classes cannot be instantiated, but still the constructor of this is still getting called somehow. When I create a circle class, the base class constructor gets called, and when I create a rectangle class, again the base class constructor gets called. This is the power of inheritance, because in inheritance, remember how it works. When you initialize a particular child object, referencing it with the parent object, see the reference is of the parent class and the object is of the child class. So whenever you do it like this, first the default constructor, because I'm calling the default constructor here, the default constructor of the circle class will get called, which will go here. Remember, I told you that Java provides the default constructor automatically if you don't provide it. So the default constructor of circle gets called, but Java sees that you are writing this code here, which says circle extends graphic object. So Java is automatically going to call the parent class and going to initialize the parent class as well, because that's how it will be able to see these methods. And so that's why it will automatically call the base class constructor, even if you don't call it explicitly. In fact, you cannot call it explicitly. Java will not allow you to initialize the graphic object class explicitly. It can only and only be called by Java itself indirectly via the concept of inheritance. If you try to do this, let's try to do this for fun and also for better understanding. So if I write graphic object go equal to new graphic object, you see I don't even get an option, but let's write it and let's see what happens. So you see that this particular, it gives basically an error because it's not able to find the constructor of the graphic object class. Though even I have defined the default constructor here, but still Java is not able to find it because this class is abstract. So Hence proved, abstract classes cannot be instantiated explicitly. They can only be instantiated by the child classes through the internal mechanisms of Java itself. And that's all I want to talk about in this particular session, where we looked in detail about the concept of abstraction. Couple of more things which I did not cover in the previous session. I just want to call them out for clarity. Java does not support multiple inheritance. When I say multiple inheritance, what it means that you will not have a scenario where a child will be extending from two base classes. Java does not support it. It does support it with the help of interfaces, but I will talk about interfaces in the coming sessions. But here, just understand this, that you cannot use multiple inheritance with classes in Java. A child cannot have two parent or two base classes in Java. Java will not allow that. It is also called the diamond problem because the child class does not know whether to follow the route of base 1 class or the base 2 class if it is extending from two different base 1 and base 2 classes. So a class can only extend from one class in Java. We can find a workaround of it by using the concept of interfaces, but that's something which will be coming later. Another thing to understand is that when you create an abstract class, here these variables, you can declare these variables as well. And these variables will be accessible by all the child classes as you access them. Let's get started with interfaces in Java. Now, again, let's understand what do we mean by an interface in general, and then we will see how do we apply the concept of interfaces in Java. So imagine, let's take the same example of vehicle industry because that's something which we see every day around ourselves and we can relate to it. So imagine if all the car manufacturers were creating a different way of driving a car. What if in one car you have a steering, but in other car you do not have a steering, but you have something else, which may be called something else. In one car you have the gas pedal to speed up. In other car, you have a button to speed up. Similarly, in one car, you may have different kind of doors, and in other car, you may have different kind of doors, which are completely different looking. It's not even a single simple handle to open it. So you see the problem here. The problem here is that all the car manufacturers are not working on a single contract. They are not respecting a single interface, which will create a poor user experience because whenever the users have to buy a new car or they have to switch from one manufacturer to other manufacturer, they are completely clueless as to how to drive that particular class because the interface they were using in the previous car is completely different from the interface they are being shown in the other car. And that's the basic need for the concept of interface. Think of it as a contract agreement. You see, it is also mentioned here that if we apply the same kind of concept to programming world, imagine if every programmer was writing their own logic in their own way without following a single contract or a single guideline. Soon it is going to create a problem. And that's the kind of problem interfaces try to solve. So interface is again a keyword in Java, and the basic idea or the basic construct is that the interfaces are going to define the specifications of how a class would act. Let me repeat this in a more generic way. Interfaces are going to define the contract or the specification which is going to govern how an application or code or programming logic will behave. That's the basic idea of interfaces. So interfaces are their own type, and the basic property of interface is that it can only contain constants, method declarations similar to abstract classes, and some default methods or static methods or nested types. What is nested type? We will cover that later. Default methods we'll touch upon a bit here, and the static methods as well. But the basic idea is that when you create an interface in Java, you cannot write anything concrete in terms of the behavior of the interface. When I say behavior, always think of that as method. So you cannot define a concrete method in an interface. You can only declare methods. You can also declare constants. You can create a particular type of concrete method by using the default keyword, but use it in very special circumstances. You can also create static methods as well, which are only going to belong to the interface and nobody else. Now let's look at an example. And also, before we go to the example, let me also phrase this here that if an interface cannot define a concrete implementation of the methods, then naturally the interface is going to be extended by a child class, a concrete class, which is going to provide the implementation of the methods declared in the interface. It does sound like abstract classes, but there is a difference. Let's understand the difference with the help of an example. This is how an interface will look like. I've used the same construct of bicycle and mountain bike just to maintain some continuity and less context switching. But this is how an interface will look like. You will not use the class keyword, but instead of that, you will use the interface keyword. You can only declare methods. You cannot define methods. Remember when we looked at the abstract classes example, we were able to define concrete methods as well. But in interface, that's a strict no-no. You cannot define concrete methods. Let me show you the abstract class in the case of abstraction which we used. This was the abstract class and it did have a concrete method, right? But bicycle.java here, which is because it's an interface, it is not going to allow you to create a concrete method. Another thing is that if you try to declare a variable inside the class, they will have to be constant. You cannot just declare them without any value. For example, I cannot do this. If I do this, it is going to give an error. You see an error here. And it says initialize field X at declaration, something like this, public static final. So interface is going to force you to declare all the variables as public static final with some value if you try to use them inside interface. So that is also something which interface will mandate. So you see interfaces are more strict. They are more strict in terms of what you can do. You can only declare public static final variables and you can only declare methods. You cannot define methods. So abstract class is less restrictive. Interface is more restrictive. And that is the differentiation which we have to keep in mind, whether to use abstract classes or whether to use interfaces. That is also a very common confusing question in the interviews as well. And remember that interfaces are only for contracts or specifications, where in case of abstract class, you can write a concrete behavior as well in terms of a concrete method in the base class. Interfaces, there's no concrete implementation in the base class. Abstract classes, yes, there can be a concrete implementation in the base class. That's the basic difference. Moving on, I have created a child class here, which is again mountain bike, and it has three properties: seat height, gear, and speed, similar to the previous example. It has a constructor, and remember, again, interfaces cannot be initialized directly, so you do not even need to call a super method here because there is nothing to initialize. You initialize a class to create a state. State is denoted by the properties, but interfaces will force you to write a public static final property and initialize its value automatically. So you do not need a constructor for the interface because there is nothing to initialize. Everything has been initialized in terms of the variables, and the methods are anywhere just declared. That's why you don't need to call super here. After that, the moment you write this particular keyword here, implements, and that is how you will basically extend from the interface. You will use the implements bicycle keyword here. Implements is the keyword and bicycle is the name of the interface. If you write this here, then Java is going to force you to provide the implementation of these two methods. If I do this implements bicycle and if I comment out these two methods, which is coming from the base class, it is going to give an error. And if I read out this error, it says either you add the unimplemented methods or you make the mountain bike class as abstract. There are two ways to fix this particular class. Similar to abstract classes, it will force you to write the implementation of the base class declared methods. Another thing which Java will suggest you and will also force you via some IDEs as well is that you use this particular annotation. We use this particular annotation to tell Java that we are overriding this method from the base class. Since apply break and speed up methods were defined here in the base class, and this child class is supposed to provide the implementation of the methods by overriding them. Overriding is again a concept which we will talk about in detail in the coming sessions. But for now, remember that you need to write this annotation here on the methods which have been taken from the base class to provide an implementation. And the implementation is similar to what we have seen before. So whatever value you supply in the apply break, the speed is going to get decremented by that particular value. And in case of speed up, Whatever value you supply in the argument, that value is going to be added to the current speed, and the speed is going to go up. Let's look at the main class here, which is called interface demo. It has a public static void main method, and here I'm again initializing the child class. Nothing strange here. And then I'm using the getter method here because I have made everything as private here, and rest of the things are just here as is. I have the getters and setters here for all the properties, and I'm using those here. So I'm using the getters to just get the value of gear, seat height, and speed, and then I'm applying the brake, and then I'm printing the current speed after applying the brakes. Let me just expand this a bit more. And then I'm using the speed up method, trying to increase the current speed of the bike by 10, and then printing the new speed again. So using the apply brake and speed up methods, which are concretely defined in the child class by using this override annotation. And these were the methods which were declared in the interface, in the base interface. And that's all which is happening in this particular class. Let's run this particular program. And these are the values I get. I get the gear as 1, which is coming from here. I get the seat height as 20, which is coming from here. I get the current bike speed as 10. This was the value which it was initialized with. Then I'm applying the brake. And after applying the brake, the speed of the bike gets reduced and it becomes 10 minus 1, which becomes 9. And that's what gets printed here. And then I'm speeding up the bike by 10. So the current value of the speed of the bike is 9. And if I incremented it by 10, it becomes 19. And that's what gets printed here. Let's get started with inheritance. So inheritance is basically one of the most important properties of any object-oriented programming language. It's basically a concept. And the concept says that what if you have a scenario where you want multiple classes to share similar behavior and similar properties. Let's understand this with the help of an example. Let's take the example of a bank. When you go to a bank to open an account, there are multiple types of accounts. There can be a savings account. It can be a type of current account. There can also be a different offering for personal account and commercial accounts, such as for businesses. Then you may also have loan accounts, which are having different kind of properties. So all of these types of accounts are still technically accounts, and they will share some similar properties. For example, all of them will have to maintain some sort of an interest rate, for example. All of them will be used to either deposit money or withdraw money. So there would be some kind of similarity across all of these types of account classes. But at the same time, there will also be some sort of differentiality amongst these classes. The way you will calculate the interest rate for a current account will be different from the way you will calculate the interest rate for a savings account. And the same applies for commercial account, personal account, loan account, etc. So you see that we have some common behavior, but at the same time, we also have some different behavior. So whenever you have such scenario, always think about applying the concept of inheritance in your application. There's another simple way to spot whether inheritance can be used at a particular place or not. Inheritance is also called is a relationship. So whenever you read the requirements from a customer, just try to find the words which use this particular phrase is a. For example, car is a vehicle. Savings account is a type of account. Similarly, you will find many other types of similar examples. So whenever you will see that is a relationship between two different kinds of objects or two different kind of entities, that means that there might be an inheritance relationship being applied between them. And that's how you will spot the usage of inheritance. So far we have understood this concept that there would be some sort of relationship between the two classes. What will be this relationship? The relationship will be of parent-child type. There will be a parent class. Some people also call that as base class. And then there will be a child class. So the child class will be inheriting the properties and the behaviors from the base class or from the parent class. I will be using base class and parent class terms interchangeably during this session. But the basic idea and basic premise is like that only, that there will be a child class and there will be a parent class. And the child class is extending from the parents class. Remember the word extend because we are going to use that. And I've just shown you the what you see here is basically the official definition, which is given by Java docs here. You can read the definition as well. And the basic idea, which I told you, lies in the parent and child relationship. And this is how you can conceptualize it, that you will have a base class or a parent class, and then you can have multiple children of it. And then those children can again have their own children, and so on and so forth. So this hierarchy, this whole inheritance hierarchy, can go as deep as you want it to be. And that's the basic idea and basic conceptualization of how you understand and how you visualize inheritance. Now let's move to Eclipse IDE and try to understand this with the help of an example. So for this particular case, I have created a set of classes basically, which we will be using to demonstrate the relationship of inheritance. And I've taken the simple example of a bicycle. So a bicycle is again a very generic definition of any two-wheeler, and bicycles can have multiple types. There can be an all-terrain bike, there can be a mountain bike, there can be a city bike, there can be a bike which is specifically made for ladies, and similarly there can be multiple different types of bikes. But all of these bikes will have some similar properties. For example, all of them will have two wheels, all of them will have a seat, all of them will have brake, all of them will have some sort of a speeding mechanism, whether they can accelerate or deaccelerate. So there will be some commonality, but at the same time, a mountain bike's features might be very different from a city bike feature. A mountain bike mountain bike might have gears, for example, whereas a city bike might not have gears, because you don't need that much of a variation in inclination and declination when you drive down the road. So I'm trying to conceptualize the same example here, where I've created a class called bicycle, and this is my base class. I define two properties in the bicycle class, which is gear and speed. We will come back to protected in a while, but let's leave that there. So I have two properties, which is gear and speed. I have a constructor where I'm initializing the starting speed and the starting gear. And then I have three methods here, which says set gear, apply brake, and speed up. When I apply brake, the speed is going to get reduced. So that's why you see minus equal to unary operator. And when I'm trying to speed up, the speed is going to increase. That's why I'm using the plus equal to unary operator. So when you use the method speed up, the speed is going to be increased by the value you supply in the method. Similarly, when you apply the brake, the speed is going to get reduced by the amount you supply in the method argument. And that is my base class: bicycle, gear, speed, and three methods. Now let's have a look at the child class. So the way you will define the inheritance relationship in Java is by using this extends keyword. Remember, I told you to remember the extends keyword. So what you will do, that you will write your class name as usual, and then you will use extends keyword, and then you will use the parent class name or the base class name. So here I'm saying class mountain bike extends bicycle. And here I'm providing an additional property. Remember the whole commonality versus differentiality equation. So a mountain bike might have an extra property to adjust the seat height. So that's the extra property which mountain bike is having. And then since this mountain bike is extending the bicycle class, this mountain bike class has the responsibility to initialize the bicycle class as well. And the way it will fulfill that responsibility is by taking all the arguments of bicycle class plus the mountain bike class in its constructor. And that's why you see three different properties here. You see the start height property, which is the property of this particular class, which is the seat height. And then you see the start speed and start gear property, which directly are not available in this class, but this class is inheriting those properties from the base class. Remember the keyword inheritance here. And then once you do that, how do you initialize the base class constructor? Is by calling the super method. This is again a keyword in Java, and you will use this super keyword to refer to the base class constructor in this way. So what you will do technically is that you will write super and you will supply the arguments which is required by the base class constructor. If I go back, the base class constructor requires two arguments, start speed and start gear. So I write super and then I write start speed and start gear. So whatever I got from here in the constructor of mountain bike, I'm supplying those values as is to super. And Java will automatically take care of invoking this particular constructor the moment it encounters this kind of statement. Another thing to notice is that this super keyword or super statement has to be the first statement inside your constructor. Remember that whenever you are dealing with inheritance and whenever you have to initialize the super class constructor or the base class constructor, use the super constructor invocation as the very first statement inside your child class constructor. Otherwise, Java will not compile the program. And then you will initialize the local variable. I should call this as this. Remember, we discussed about this in the classes session. Okay, and then it just has a method of set height. So there's no extra method which this mountain bike is providing, but this mountain bike will have access to all the methods which have been provided here and all the properties which have been provided here. This mountain bike can access everything from the bicycle class. And that's the whole idea of inheritance, that the child class can access the properties of the base class by extending the base class. Now let's look at how do we invoke this particular class. So for that, I have a simple class name as inheritance demo, which has a public static void main method. And then I am initializing the mountain bike class. I'm supplying three values as 20, 10, and 1. So the 20 goes to start height. The 10 here goes to start speed. And 1 here goes to gear or the start gear. And that's how I'm setting the values. So when I call this particular constructor here, the mountain bike constructor is going to, mountain bike constructor is going to get called, and which in turn is going to call the base class bicycle class constructor as well, and everything will be set accordingly. And then let's try to access the gear property. Remember, gear is not directly available in the mountain bike class, but I'm still able to do mountain bike.gear because child class can access the parents class properties. Similarly, the same thing goes for speed as well. And seat height is the local property of this particular class, mountain bike. So it will anyways be accessible. So I can access all the properties of the base class and the child class itself seamlessly without any differentiation. Now let's try to call a method. So here I'm calling the method apply break. Remember, apply break was defined in the base class, not in the child class. It's defined here. So I'm calling the apply break method and I want to reduce the speed, the current speed by 1. And then I'm printing the current speed, saying that bike speed after applying break is mountain bike.speed. So let's run this particular program and observe the outputs. Okay, so the first statement which gets printed is at line number 7, which says gear is 1 because it's coming from here. Then the seat height is mountain bike.seat height, which is 20, which is the first argument here. And then the bike speed is 10, which is coming as here and getting printed here. And then when I apply the brake, let's go back to the apply brake method. The logic is that whatever is the current speed, reduce it by the value I supply in the method. So if I supply 1, 10 minus 1 becomes 9, and that becomes the current speed. If I supply 5 here, the current speed will be 10 minus 5 equal to 5. Let's assert that particular assumption as well. Yes, we can see that. And similarly, you can access other methods of the base class as well. If I just do control space here, and you can see apply brake is accessible, set gear, set height, speed up, all the methods which are defined in the base class are accessible in the child class as well. This is the power of inheritance. One more thing which I said I will come back to is around the usage of protected access modifier. Remember when we discussed about the access modifiers in the previous session, I said that protected is used when you are dealing with inheritance, that whenever you define something as protected, it will be available to be accessible in the child classes of the base class. So if I define this particular variable as protected, then this particular property will be accessible in the child class mountain bike as well. Let's play around this. Let's make this as private and see what happens. So if I make this private, now when I say private, the scope of this particular variable is within the class only, and nobody outside the class will be able to see it. And you can see the effect of it. I can see an error being coming here in my inheritance demo class because now mountain bike object cannot access the gear property because the gear property is defined in the base class and now it is private. That's why the child class now, mountain bike class, cannot access the property gear. And the moment you make it back to protected, it will be accessible. The error is gone. There's no red line here. So that's how you can use the protected access modifiers. It is always recommended to use them when you write any kind of inheritance logic. And in inheritance logic as well, intentionally, if you want to hide a particular property from the child classes, just make it private. And that's all I want to cover in this particular session, where we dive deep into the concept of inheritance. We had a look at an example using the bicycle and mountain bike kind of construct, and you can apply the same kind of construct on any kind of other kind of business requirement. Remember, the is a relationship. Let's get started with walking through a particular project using all the concepts which we have learned so far. So in this session, we are going to focus on a particular project, and the project we are going to focus is about an ATM application. So you might have interacted with different ATM stores in your cities where you go in, you insert your card, you enter your PIN, and then you can view the balance, you can withdraw some amount, you can also deposit some amount from the ATM. So we will try to look at it from that perspective, and we will see what kind of different Java and OOPS concepts we can use to build such ATM application. This is not a super versatile application, but this is just to give you the idea of how to use those OOPS concepts to build a simple or a complex Java application. So let's start from the options menu class, because that will give us the understanding of what kind of functionality I'm using. And here you will use that I'm using different concepts which I have taught you so far in this particular series. So for example, we are using the IO exception, we are using the hash map class, we are also using a scanner class, which is used to take input from the command line. So this option menu class is extending the account class, and I will come to the account class in a while, but let's see what this option menu class is doing. This particular class has it is using a decimal format money format class, which is to denote what kind of format of money you have. Then we have a hash map, which is storing the couple of records of account number to PIN mapping. So we create a map, and inside the get login method, we add couple of entries to the map. Here, the first entry, the first integer, is pointing to the customer number, and the second integer is pointing to the PIN of the account of this particular customer number. So if we call the get login method, this method will insert the data. After that, it will ask the customer to enter the customer number, which has to be one of these two. If you provide any other value, then there should be a logic in the application to reject the input. So whatever customer number the customer inputs, we pass that inside this particular method called set customer number. Again, I will come back to that. And once you have provided a valid customer number, then this method is going to ask you to enter a PIN number. And remember, I told you this is the customer number to the PIN number mapping. So whatever customer number you select from here, you will be providing the corresponding PIN number. And again, if you provide an invalid PIN number, you will get an error. So that will all happen inside this try block. And if you enter any invalid characters in the PIN number or the ATM customer number, then you will get an exception, which I am writing inside the catch block. This is all what we have seen so far. After the successful enter of the customer number and the PIN number, I fetch those values from these two methods. Again, I will talk about what these methods are doing. And again, I'm doing some basic validation checks, but things get interesting in this method. So what we covered so far was the get login method. Let me close this method here. So we covered the get login method. The second method, which is defined in this particular class, is the account type. So here we will ask once the customer has provided the customer number and the PIN number, we will ask the customer to provide the account type. This application supports two different account types, which are checking account or a savings account. So the customer has to choose one of them. Again, we will be taking the input from the command line using the scanner class. And then I'm using a switch case. If the customer entered 1, then I will execute some code for the checking account, which is defined here in the case 1. And if the customer entered 2, then the case 2 will be executed. And if it enters 3, then I will exit the application by just printing a sys out. So here I'm using the switch case construct to provide different options to the customer. There's also a default case specified here, which says invalid choice. So this is what is happening in the get account type method. The next method is if the customer has used the option 1, then we call the get checking method. So let's go to the get checking method, which is the next method which is defined in this particular class. So if the customer has selected a checking account, then we provide the following functionality to the customer, which is the customer can view the balance, Customer can withdraw the funds, customer can deposit the funds to the checking account, or they can just exit the application. And again, I'm using a switch case here based on the customer types 1, 2, 3, or 4. The corresponding case block will be executed. For example, if the customer wants to view the balance, then this block will get executed, and I call the get account type method. If the customer selects the 2 as the withdraw fund, then get checkings with withdraw input method gets called, and then get account type gets called. Similarly, if the customer enters 3, then we deposit the fund, and for that also I have defined a method. I will go to the definition of these methods as we go along, but right now we are just building the framework. So the get checking deposit input method will be called whenever the customer selects the option 3. And for option 4, we just exit the application. So this is what is happening in the get checking method. Now, if from the account selection, if the customer selected second option, which was savings account, then we were calling get saving method. So this is where the get saving method is defined. And again, it is following the exact same format as we saw in the get checking method, where we present the following options like viewing balance, withdrawing the funds, and depositing the funds in the savings account. And I have some methods defined here. For example, get saving withdraw input, get saving deposit input. So we define the switch case here based on the customer's choices here. And that is what is happening in the get saving method. So let me close this method as well. And that's all what is defined inside the option menu class. So we ask the customer to enter the customer number, the PIN number from this get login method. Then based on that, we provide the customer the options to choose the account type, whether they can choose the savings account or the checking account. And based on that, whatever account type they use, we call the get checking or get saving method. And inside this method, we provide the customer the other options to either withdraw the money, deposit the money, or view the balance. That is what is happening inside this option menu class. Now let's go to the account class, and all the methods which we saw here will be provided a definition in the account class. You also see this option menu is extending the accounts class, so an inheritance concept is being used here. Let's go to the account class now. So this is the account class where I have defined some private member variables like customer number. So now you will be familiar with the customer number, PIN number, which I just described, and also with the checking balance and the savings balance. You can also divide this account class into two child classes where you have a savings account class and a checking account class. But for simplicity, I've kept it to one class. I'm initializing a scanner input which will be used at multiple places. And then I have the setters and getters for these 4 member variables. So you see set customer number, get customer number. If you remember, this set customer number was called in the option menu class. If I go back to the get login, once we ask the customer to enter the customer number, we call the set customer number, which gets called here. Similarly, we call the set PIN number, which gets called here. Similarly, once we have set that, we were fetching the values using the get customer number and the get PIN number. And that is also defined here in terms of the getters, get PIN number and get customer number. Similarly, we also have the getters for the checking balance and the saving balance member variables. We do not have the setters for them because they are not technically setters, but we have to calculate the balance. It's not a simple setter where you can just return the value. So now let's look at some of the business functions of the account class. How do you deposit? How do you view the balance? How do you withdraw the balance, etc. So you see these 2 methods, which are specifically when the customer is trying to withdraw the money from their account. And these methods are basically called internally by other methods. So we will come to that. Let's just understand that we have 2 methods for calculating the withdrawable amount or executing the withdraw transaction for the checking account and the savings account. Similarly, I have 2 more methods here, which are calculating the depositing for the checking account and calculating the depositing for the savings account. And then we get the bigger methods, which are using these calculation methods. So I defined 4 calculation methods so far: calc checking withdraw, calc saving withdraw, calc checking deposit, and calc saving deposit. Basically withdrawing and deposit for both of the classes. And then we have these business functions called get checking withdraw input and get saving withdraw input, get checking deposit input, and get saving deposit input. So these getter methods are something which were being called from the option menu class, if you remember. If you go back to the option menu class, and if you chose the checking account, you get these options. And let's say you chose option 2, which was withdraw funds, or option 3, which was deposit funds. then the corresponding methods which were being called were get checking withdraw input and get checking deposit input. And this is the exact same method, get checking withdraw input and get checking deposit input. So if you see what is happening inside this particular method is a couple of sysouts. Then we take the scanner input amount and we convert that amount to the double. After that, we check if the amount which the customer wants to withdraw is smaller than the checking balance or not. And I'm running this condition to check that. If the amount is smaller than the checking balance, then we call the calc checking withdraw method, which was defined right here. Remember, I told you that these 4 calc methods will be used, and this is how they are used. So here I'm actually subtracting the value. So whatever amount the customer wants to withdraw, subtract that from the main balance and then return the new main balance. That's what you do, right? If you have 1,000 rupees and if you want to withdraw 500, you subtract 500 from 1,000 and then you send back the remaining balance. So that is what is happening when we call this method, and then we print the new checking account balance. That is what is happening in the get checking withdraw input method. Similarly, if you chose option 3, which was depositing funds to the checking account, then get checking deposit input gets called, and it is defined right here, get checking deposit input. And here, instead of subtraction, we are doing the addition. So here I'm again doing a condition check that the current balance plus the new amount which has been supplied by the customer from the command line, the total sum of it should be greater than 0. What if the customer entered an amount minus 5,000? I should not allow that. So that's the reason I'm putting this condition in place. And if the current balance plus the new amount which is supposed to be deposited to the account, the sum of it is greater than 0, then call the calc checking deposit method. And this is where the calc checking deposit method is present, and where I'm just doing present balance plus the new amount and returning the new balance. That's all which is being done here. And you will see exactly similar logic running for the savings account as well. If you look at the get saving withdraw input, which is used to withdraw money from the savings account. So I take the input from the command line and I run a condition check that the amount which the customer wants to withdraw should be less than the current saving account's balance. If yes, then call calc saving withdraw method, which is defined here, where I subtract the amount from the current balance and I return the new balance. And similarly, you will see the exact same functionality in the get saving deposit, where we add the money instead of subtracting the money. And this is all what is defined in the account class. So we talked about the option menu class, we talked about the account class, and now we have the ATM class, which is the entry point, which basically initializes the option menu class and calls the get login method. Remember, get login was the first method which asked you to provide the customer number, and then get login called the method to choose the account type, and the account type methods then called the method to choose the option to withdraw, deposit, or exit. So now we have built a fair understanding of what is happening in this application. So let's run this application. So I just ran this application, and let me bring the console here. It's first asking for a customer number. So I will go to the option menu class and I will pick up one of the customer number which I have hard coded here. So I will provide that customer number and hit enter. Then it asks me for the PIN number. So remember, you have to provide the correct PIN number corresponding to the customer number. So I'm taking this PIN number, just copying it and pasting it here. Then this whole code got executed, and then it called the get account type, and the get account type method provided you with these options, which you see here on the screen. So based on what you select, the case block will get executed. And let's say I want to go for a checking account. So I press 1 and I hit enter. Once you select the checking account, the case 1 gets selected and it calls the get checking method. And the get checking method again provides you with another menu to withdraw, view, withdraw, or deposit or exit. So let's say I want to deposit funds. So I press 3 and hit enter. It says the current balance is 0 and enter the amount you want to deposit. Let's say I want to deposit 500 and I hit enter. You get the message saying the new checking account balance is 500 and you have successfully deposited the money. And that is what I did for the checking account. Now let's try to withdraw something from the checking account. So you again get back the same option, because inside the get checking method, we call once we have successfully done the business operation, we again call the account type method to display the menu again to the user. So let's say again select the checking account class. And this time I want to withdraw the funds. Remember, I've added 500 there. So let's say I want to withdraw. So I choose the option 2 as the choice. Current balance is 500. and it's asking me the amount you want to withdraw from the checking account. So I enter, let's say 100, and I hit enter. When I do that, the new checking account balance becomes 400. So the 100 got subtracted from the 500 and the new balance is shown to your screen. You can do exactly the same thing for the savings account as well. And let's also run a negative condition. So I again select the checking account and I want to withdraw the funds. So I choose the option 2. Current balance is 400 and I would like to withdraw 1000. What happens? If you do that, we get a message saying balance cannot be negative. And this is coming from the calc checking method, which is defined here. So what is happening that I wanted to withdraw the funds from the checking account, and here get checking withdraw input got called. Here, this condition was checked. So the checking balance was 400 and the amount I wanted to withdraw was 1000. So 400 minus 1000 is not greater than equal to 0. So it jumped into the else block and it said balance cannot be negative. So this is how you can also build some error conditions in your code which are mandatory and which should be built. Otherwise your application will have a lot of bugs. We can also exit the application. So if you just type 3 and hit enter, you will exit from the application and it will again call the login method where it will again ask you to enter the customer number. So this is how you can run this application, and this was a simple use case for you to show how you can use the different object-oriented concepts like classes, objects, methods, setters, getters, switch case, etc. to build the application with the correct business logic. Let's get started with walking through a core Java project using all the different OOPS concept we have learned so far. So in this example, we are going to have a look at a calculator application. And this calculator application supports primarily 4 different operations like addition, subtraction, multiplication, and division. So let's see how do we build that app. So in front of me right now is open the main class. So I have a main app class here, which has a public static void main method. And the first thing we see is a read input class, which is calling a read method. So if you go to the read input class, it has a simple static method here, which is the read method, and it is using the scanner class. If you remember, I talked about the scanner class, which is used to take inputs from the command line from the user. So we initialize the scanner class and we start taking the inputs, and whatever the user inputs in terms of the expression, let's say the user entered 4 plus 5 or whatever, that whole expression gets sent back into this input line as a string. And that comes back here in the input expression. Once we have captured the input expression, the next thing we do is divide the input expression in the numbers and the operators. Basically, an expression would be either something like 4 plus 5 into 3 divided by 2, let's say. Let's say the user entered this expression. So this has either numbers or operators. So that's what we are doing here. We are using the split method of the string API, the string class basically. And this split method is going to split the numbers and operators into 2 different string arrays. And here I'm providing the split expression that split at every time you encounter one of these symbols. So this, when you execute this particular statement, it is going to return a numbers array which will be created based on this expression. So you will get an array with 4, 5, 3, and 2. And similarly, in the operator array, you are going to split or pick out the elements every time you receive a number. So this operator array is going to hold this plus sign, this multiply sign, and this divide sign. Hope you get the understanding that we are just splitting the whole expression into 2 different arrays, where first array is holding only the numbers and no mathematical expressions, and second array is just holding the mathematical operators and no numbers. And we'll see why we need to do that in the upcoming lines. Once I've created this string array, I just want to store or convert these string arrays into a queue. So I convert this array into a list by calling the array.asList. So this expression is going to return a list. And then I'm going to convert this normal list into a linked list, and then going to store this linked list into the queue of numbers. And I'm going to do exactly the same thing for the operator array as well, converting this into a generic list, converting that generic list into a linked list, and then storing this linked list as a queue. So I have an operators queue and I have a numbers queue. Both of them have been stored into a queue now. And then I'm using the poll method. If you remember, the poll method of the queue is used when you want to fetch the first front element, the head element of the queue. So whichever element is sitting at the head of the queue will be taken out the moment you call the poll method. So I fetch the first number from the numbers queue. So in this case, 4 will be fetched here in this variable. And after that, I run a loop on the numbers queue. And I'm going to run this particular loop till this particular queue is not empty. If you see, there's a negation here. So I'm going to pick up numbers one by one from this numbers queue till the number queue becomes empty. And inside the loop, I do the exact same poll operation for the operations queue. So this operations queue is holding all these mathematical operations like plus, star, and divide. So I'm going to pick the head of it. So in this case, plus will be picked up and will be stored in this variable called OPR. And then I'm going to run a switch case on this OPR. Basically, as I told you, in this particular calculator application, we are supporting 4 operations, which are addition, subtraction, multiplication, and division. So I define a case for each of the mathematical expression. So you see there are 4 different cases here. And for each case, I'm initializing a class. If it's a plus sign, then I'm initializing the add class. If it's a minus sign, then I'm initializing the subtract class. For multiplication, I have a class called multiply. And for division, I have a class called divide. Let's have a look at what these classes are containing. So if I go to the add class, first of all, it is implementing an interface called operate. And this operate interface has just a single method called getResults, which is accepting a variable argument array. If you remember, I told you that you can also use a var_arg array. This is called a var_arg expression. This means that this numbers will be an array of arbitrary length. It can be a 1-element array, it can be a 2-element array, it can be a 4-element array, or whatever you supply. But it is still going to be a fixed length array, but the length is going to be dependent upon how much argument you supply to this particular method. So that is what this interface operate is doing. It just has one method declared, which is called getResult, which is accepting an array of numbers. So if the add class is implementing the operate interface, then it has to override the getResult method. And here it is just doing a summation of all the numbers which have been supplied. So if you supply 4 numbers, it is just going to add up those 4 numbers and return the sum. And the exact same kind of logic or similar logic will be seen in other operate classes. So if I go to the subtract class, it runs the exact same operation, but it subtracts the values. If I go to the multiply class, it is also implementing the operate interface. And in the get result, it is just multiplying all the values. Similarly, in the divide class, it is also implementing the operate interface and it is dividing all the numbers one by one. So it's doing pretty much the same thing in terms of the expression and the logic. The only difference is whether you are using an add operation or a subtract or a multiply or a divide. So we have checked all these classes and the operate interface as well. And let's go back to the main app now. Now you also see that I've defined a reference of operate here, and each of the switch case block, I'm assigning the object type to this interface reference. So I'm using the concept of dynamic binding, which we talked about when we talked about interfaces, that we can also do dynamic binding where we can assign an object to an interface type, and the object type will depend upon the expression. So once we have filled that based on the case, while filtering out this expression and picking up plus, star, and divide sequentially, then we go to the next line outside the switch case block, which is to pick the next number from the queue. Remember, we already did one poll here. So as per this example, 4 was here in this res. And now when we do this number.poll again, 5 will be picked up because that will be the next head of the queue. So we pick up 5 here and then we call operate.getResult. Now this getResult will be called based on the expression which was encountered first in the queue. Again, looking at the example, the first expression encountered will be plus. So the expression was plus. So the operate type object is of add type. And when you call operate.getResult, the getResult method of add class is going to get invoked and it is going to sum 4 and 5. This res is holding 4 right now based on what I described here, numbers.poll. And this num is holding the second operand, basically 5 here. So 4 plus 5 gets evaluated here in this case. And then it again goes back here and it checks if the number q is now empty. No, it is still not empty because we still have 3 and 2 left there. So again, it does the operations.poll and it picks up multiply sign here. Then it again runs the switch case. Since it's a multiply sign, it will go here and it will initialize the operate interface reference as the object of multiply class. Then coming here, it will do a numbers.poll. And this time the numbers.poll is going to pick up 3. So 3 will be picked up here. And then the current value of result, which is already 9, 4 plus 5 was 9. The current value of result will be updated here. So res will be 9 here and num will be 3 here. And when you call operate.getResult, the multiply classes getResult will get called and it will say 9 into 3, which will become 27. It will again go back here to this particular line and it will check again if the numbers queue is now empty. No, it is still not empty because we still have one element left. Then it polls the queue of the operations where the expression divide is present there, which is the only element left in this particular operations queue. And since we have the OPR value as divide, this case block gets called and the new divide class gets initialized. The divide class basically gets initialized and we come here and we do numbers.poll. Now the last number which is available in this queue is 2, which gets picked up here. And then we again call operate.getResult. This time, since the operate operate reference type was of divide class type, so when we call operate.getResult, the divide operation or the getResult method of the divide class, basically this method will get invoked and it will divide the current value of result, which was 4 plus 5, 9 into 3, which was 27. So it is going to divide 27 by 2, which was the last value of the numbers.poll. So it is going to execute 27 by 2 and whatever value it gets, it is going to store the result value back into the rest variable. And then it is again going to go back here and again going to check the condition if the numbers queue is not empty, but now the numbers queue is empty because 2 was the last element. So it is going to come out of the loop and it is going to print the final result. That is how this whole program is working. Now let's try to see this in action and we'll try to execute the exact same expression. So if I right click and go to run as and run this as Java application and I supply an expression saying 4 plus 5 star 3 divide 2. And if I now hit enter, I get the value as 13.5, which is exactly what we ran through because 4 plus 5 will be evaluated first, which will result into 9. Then 9 into 3 will be 27 and 27 divided by 2 will be 13.5 exactly. So this is how this whole program is running, where we first take the inputs and then we divide the input into numbers and operation arrays or in fact queues. And once we have those queues built up, then we pick up the first number and we keep running this loop till the numbers queue is not empty. Inside the while loop, at each step, we pick up the first expression or the operator. We check what is the operator, whether it is an addition, subtraction, multiplication, or division operator. And whatever kind of operator we have, we initialize the corresponding class of it. And then we fetch the next value in the numbers queue. And then we call the get result based on the expression. And whatever result we get from the get result, we store it back into the rest variable. So we keep updating the rest variable at every step. That's the reason the result of 4 plus 5 gets stored in the rest. And next time you are calling the get result for a multiply operation, here the rest value is 9 now, and it says 9 into 3. Again, in the next time, the rest value will be updated to 27 because we are storing the result back into the result variable. So this is all I want to cover in this particular session, where we looked at an example of a calculator application purely from the console standpoint. Obviously, there can be a lot more stuff which we can do into this particular application, make it more error-free and cover a lot of corner cases like validating the inputs, etc. Also looking at putting some conditions around the exception handling the divide by zero scenario, etc., which is not here. But this is just to show you the basic idea of how you can build simple to complex CLI applications using the core Java concepts. So that's all I want to cover in this particular session. If you like this video, a thumbs up will be massively appreciated. Thank you, and we'll meet again in the next session.
And with that, we have come to an end of this particular tutorial on object-oriented programming in Java. If you have any queries regarding the topics covered in this session, then please feel free to ask them down in the comment section below. Our team of experts will be happy to resolve all your queries. Until next time, thank you, stay safe, and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.